drawing Lewis dot structures with triple bonds. In this problem, it says which of the following is the correct Lewis dot structure for N2. So we're going to draw the Lewis dot structure and find out which one of the answers match up with what our correct drawing of the Lewis dot structure is. So first we're going to draw the two ends, the symbols of the two ends, and we have to know how many valence electrons nitrogen has. So nitrogen, we go to the periodic table, and when we go to the periodic table, we see that nitrogen is in group 5A, so that means it has 5 valence electrons. So 5 valence electrons, I'm going to put VE for valence electron, plus 5 valence electrons, which equals total 10 valence electrons. That means that's the total that we're going to have in this bond together with two nitrogens in this bond. So what's going to happen is we're going to see how we can get a total of 10 valence electrons and satisfy the octet rule. So what we're going to do first is we're going to do this. We're going to draw the 5 dots that it needs. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it has 5 bonds. So it has 1, 2, 3, 4, 5. It wants how many more valence electrons? 3, because we know we want 8 valence electrons to be happy. So what's going to happen is it's going to share between these two. That makes it now have 1, 2, 3, 4, 5, 6 valence electrons. That's not enough, and it wants 2 more. So what's going to happen is this nitrogen is also going to share this pair of electrons. So that's going to be 1, 2, 3, 4, 5, 6, 7. But that's not, still 7 is close, but no cigar. It's not exactly what we want. We want 8. So we're going to do this. I'm going to put one more bond. So 1, 2, 3, 4, 5, 6, 7, 8. Now this end has 8 valence electrons. Let's check the other end and see if it has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. So this is a Lewis dot structure with these are not being shared, but they are part of the electrons that are floating around N, these individual ends, and these ones are sharing. This is why this triple bond has formed, so that these two ends can have their 8 valence electrons, can feel stable. So let's see which one of these answers matches up with what we've drawn here. And as we can see, A doesn't match, D doesn't match, and C doesn't match. And we want to check if they have 10 valence electrons. So you can count up the valence electrons and see if they do have those valence electrons. And if they don't, we know that's the incorrect Lewis dot structure. So B is the only answer that matches ours and has the correct number of valence electrons. So that is the answer to this problem.